Now we're going to talk briefly about assignment statements. Assignment statements are those that involve an equal sign and produce a result of some kind on one side of the equal sign and then stores it in the variable that's named on the other side. So let's take a look. The first thing we need to mention is the idea of syntax. The syntax for an assignment statement is very specific. Syntax just means rules in programming, and every language has its own set of rules for how a statement should look. One thing that you already know is that you need to end your statements with semicolons, and that's how the compiler knows that you're done with one set of instructions. Let's take a look at this statement right here. We've declared a new variable x of type integer, and we are storing in it the value 8. Now this is a valid Java statement, and essentially what it does is it looks on the right-hand side where the 8 is. It would do any evaluation that needs to do there if there was some kind of arithmetic, and it will store the result in the variable x. And what does that really mean? Well, behind the scenes, it knows that x is it's just an arbitrary name, but it means that there's some place in memory that the program is set aside for values that are referenced by x. And so it's going to put the value 8 inside that space in memory, which will be 4 bytes because that's how large it knows to make an integer value. That's what we call an abstraction, by the way. And it's not something that you need to worry about too much, which is part of the nice thing in programming, is that we abstract a lot of machine level details so you can focus on writing the code at the high level. This is another valid statement. Here we're actually doing an expression on the right-hand side. So we're taking 12.0 and dividing it by 5. Notice we're using the 0.0 trick to kind of declare 12 as a floating point number, so that way when the statement is executed, it will actually evaluate to a decimal value. And then we're storing it in a variable called y, which is a double, which means 8 bytes. In general, what you need to remember is an assignment statement has a variable on the left-hand side, and then it has an expression to evaluate on the right-hand side. There are certain rules for variables, and we should make sure that we know these as well. First of all, we have to declare a variable with its type before we use it. Now, you don't have to declare it every time you use it. In fact, you shouldn't do that. If you declare the type, and when I say declare, what I mean is that you put the type of variable that you'd like to create. If you put that type in front of the variable name, it will create new memory every time you do that. So you just need to declare it once. Secondly, the name should be unique for the scope. We haven't talked much about scope yet. Scope is defined in a programming language like Java by the curly braces. And really what it means is it tells the computer the location in the code where it should actually bother reserving space for a given variable. Once you leave scope, the garbage collector, which is a Java feature, will essentially eliminate that space in memory and allow it to be used by other parts of the program. We're going to talk about scope in more detail later, but just know that if you see a set of curly braces and there's a variable declared inside the curly braces, you're not going to be able to use the variable outside the curly braces. Okay. Now the third bullet point there is that states that a variable should be initialized. What you should know off the bat is that in most cases, if it's a numerical type, the variable is going to be initialized by default to 0. But I think for clarity's sake, it's good to state that you're going to set a value to 0. Makes it a lot easier to read for someone who's coming back to look at your code later. And it kind of reminds you where your starting point is. Now you can initialize it to whatever value you like, but 0 is always a good default value. Now if you look at these statements that we've written at the bottom here in the example, we have 4 statements. The first one involves the declaration of x. It's an integer, set to 0. The second statement now stores or assigns the value 13 to the variable x. What I wanted to point out with these examples is the fact that you can actually use variables on the right-hand side, and those variables will eventually involve a substitution. So let's look at that third statement, x equals y plus 1. When that code is read, if there's a variable called y, it will substitute the value stored in y, where you see the letter y on the right-hand side, and then evaluate the expression. Lastly, it'll store the result of that expression's evaluation into x. Now, you'll notice I put a little comment there at the end that says bad if y has not yet been declared. And I didn't write that, so I wanted to make sure that you understood that if we haven't declared a variable called y, that statement won't compile because it hasn't seen that variable yet. The fourth statement says x equals x plus 1, and that's kind of counterintuitive from an algebraic standpoint, right? How can x be equal to 1 more than itself? But that's the thing about programming that is important to remember. The right-hand side gets evaluated. The left-hand side is where that answer goes. So in this case, it'll substitute the value for x in for the x that you see on the right-hand side. It'll evaluate that expression and then store it back into that memory location, overwriting the previous value in x. So for instance, x is 13. We add 1 to that, it's 14, and now x will store 14. And it'll actually write that over the 13 in memory. So as a summary, let's remember these things. First of all, the right-hand side is evaluated first. Secondly, when we get the result of the right-hand side, we store it in the variable that's named on the left-hand side. And lastly, and I didn't give an example of this, but the left-hand side can only contain a variable name. It cannot contain expressions. So I will give you an example now. I could not write y plus 3 equals x, because y plus 3 would be on the left-hand side. If I wanted to evaluate y plus 3 and store it in x, I would have to write it x equals y plus 3.